Okay, so I continue with my introduction to QGIS software, the interface, the user, what we call the integrated development environment. So like this is the, this what you see when you open the software. Are you okay? The GUI, the graphical user interface, that's the better word for it. Integrated development environment to be for software development. So please, we shouldn't confuse that. So editing, we have the usual thing, copying and things like that. Are you okay? You can see add ring, add parts. All these are for editing of a feature. When you draw a line and you want to cut a line and things like that, but we wouldn't be using that. Let's see, we have the view menu, which allows you to see some of the things, the panels. Yeah, if the layers panel disappear, you can bring it back. So if all of a sudden you fidget with it and you close it, come to the view menu and then switch it back on, so that you have your layers panel back on again. You understand how this works in a minute. Is that all right? You have the settings are setting, you want to change the style, keyboard, options, it's the same. Plugins, QGIS makes use of plugins. Plugins are like extra, they are like something extra. Not the main software, but something you can add to the QGIS, the course, the software itself. You can create your own plugin. That is the interesting thing about this. And it makes use of Python. If you like programming, this should be an exciting thing for you. So, for example, split features on steroids is someone's plugin that they created. Vector menu contains a lot of vector operations. So remember, vector stands for lines, points, and polygons. Okay, so you have a whole lot of things that you can do. Okay, geometry tools, analysis tools. You can have research tools so that you can actually create a scenario. Are you okay? You can create random points all over an area and say, let's assume all these points were, boreholes, for example. All right. Geoprocessing tools. Now we talk about buffering. So you can see buffer. You can have. David, mute your mic. I don't care if you're angry. Mute your mic. So back to what we're doing. David disrupted everyone. They even apologize. Anyway, so now we have a whole lot of vector things. So when it comes to vector, it's lines, points, and polygons. So all the operations here are on lines, points, and polygons. Okay. And then remember that when it comes to vector, vector is stored in GIS as a table. So in the table, you have nodes, and then when you have two nodes, then you can join them with an arc, and then arcs form polygons, the topology thing. So you can talk about data management as well, because you are dealing with tables, you see. So that's the connection. Raster menu also deals with everything raster. Raster means image or picture. Please don't go into your exam and give me any funny thing about raster. I will give you 0. Raster is about images. So that's what this practical is for. Come to with some reality of what I'm talking about. I've given you an image on WhatsApp, and that image is actually a raster. Put it in your mind. Okay, put it in your head. Okay. All right, you can also put it in your mind. Now, so we can do what we call georeferencing. So today, our main tutorial is on what we call the georeferencing. Okay. We do the tutorial to bring understanding. So I want you to take it personal and understand it. You can then go into exam and just score 90 over 100. That will be just fun, and I'll be very happy person. So remember the essence of the tutorial. So there's a whole lot of things you can do with the raster. You can clip a raster by extension. You can, clipping is clipping. Clipping is really like cutting a part of. Okay, when you talk about clipping, you think about a clip, yeah? A clip kind of the way we know clips, but in GIS, clipping means you are cutting a part of something. All right, it's not like the clip that you use on your clothes. Conversion, we can do what we call rasterization. So we can move from lines, points, and polygons to pixels, okay, by using the rasterize function. So that one, we'll talk more about the 13th, before we meet again. We'll be talking about that. Why? Because then we're doing the suitability analysis. All our data will have to be converted to raster, and then we compute, we generate a final combined raster. Okay, I want to say, use these technologies. You get used to it, and then you pass the course easily because the exam carries a large mark. All right, so now, so we move on to database facts. You may not need this, but the interesting thing is that databases are very important with GIS. We have what we call the spatial databases. That is not why I came. Okay, to meet you guys. The whole database thing probably is not for you, but put it in your mind that GIS can be considered as a database. Remember the definition of GIS? One of them is the database definition of GIS, where GIS is seen to be a database in which all objects stored in it are actually spatially indexed. Remember we talked about this in class. Please don't forget the things that we talked about. The videos are also there. You can make references to them. So web, you can create a web page straight from the QGIS. You can just shift everything you've done and then visualize it. I think for now, it may not look interesting, but you will understand later on if you're interested. So this SCP here is a plugin. So I want you to understand that there are so many plugins that can be, used in GIS. So all you need to do is to go to the plugins menu. Okay, the processing to the city. So here, I don't know if you can see this dialog on the screen right now, but this is where you get your plugins. Are you okay? So for example, the georeferencer. Today we are going to do georeferencing. Okay. The georeferencer should be here. It's not here because it's already there. But you can see there's a freehand raster georeferencer. So there are loads of, toolboxes. We used to have something on roads, point road sign, etc. People have developed these things. So every single one of these is like an extension to the main QGIS software. All right, enough. If you need help, you just go to the help menu, and then you can now go for documentation. All right, every good software should have documentation. Okay, someone's hand is up. So let me hear you. I don't know if you just raise your hand for no reason or you did raise it.
Yes, sir. Sir,
yes, Michael.
You're saying QGIS. Yes, sir. Please, I wanted to know what the Q stands for.
Okay, that means you missed the lecture, but it's okay. I'll forgive you. Now in church, we are talking about
Thank you, sir.
Yes. So I'm forgiving people. All right, Michael. So the Q is quantum GIS, and the GIS itself stands for Geographical Information Systems. So yes, that is it. Quantum doesn't mean anything. It's just a name. People give interesting names to projects. So it doesn't. It's got nothing to do with quantum physics. Okay. All right. GIS is just GIS. Except that I think it's a very nice name to give to it. All right. So moving on. Yeah. Where was I? So done with all these menus and then what the menus can do. All right. So now we are going to carry on with our georeferencing. So we'll start by opening the georeferencer. Those of us with the software, go to the raster menu and then go to georeferencer and then click it. So raster menu, georeferencer, and then I want to see you click the georeferencer. So raster menu. And then georeferencer. So this is like step 4. I didn't record the previous steps, but yes. This is where we are. We are at step 4. You've opened your software, you've looked out for your data sources, and now you've just gone to the raster menu and then you've clicked the georeferencing. So that should bring up a dialog box. It may just take the whole screen. You may see it as full screen, open to full screen, but that's okay. There's nothing wrong with that. Can you all see my new interface with the georeference at the top? Can you? And have you?
Yes,
opened? Yeah. Okay. You
yes,
can. Okay. Okay. Great. So, what is georeferencing? Georeferencing really is about associating geographic coordinates with an image, so that you can actually, use the image in a certain context, so that you can overlay the image with other data sources. Okay, normally images are used as a background, as a backdrop, some kind of thing like that, a reference. So what we're going to do today is that since I've given you a picture, the picture is just a picture anybody could have taken, anybody could have done a screenshot. So that's what I sent to you on WhatsApp. All right, now we want to take that image and I want to give it coordinates so that they become real. So normally you georeference a satellite image or an old map, an old scanned map. Okay, an old scanned map. Why? Because the world is very new. We just didn't start seeing computers. We just started seeing computers. There was no computer some years, but not too long ago. Are you okay? For like 100 years, people never knew anything about the things we are doing today. So since 1950, from 50s coming, like you can imagine that computers were like, nobody really wanted to use a computer. Are you with me? So a lot of data exists as paper, on paper and analog. And when you are able to scan it, the first step has been done, which means that you have computerized the data you have, the hard copy. The next thing is to now be able to overlay data that you have today, like GPS data. Okay, let's assume you went out, you picked an old map from Ghana Water Company and you scanned it, then you georeference it, then you can now go and pick some GPS coordinates, overlay it, then you now see, oh, okay, so in 1954 there was a pipe, are you okay, a conduit here, there was this, facility here that allows water to flow here. Are you with me? Then it can inform your present actions. Not just call some consultants who start all over again. It's like, Charlie, forget about everything you've done all the years. All right. So now we are going to use the georeferencer to carry out this, and then you will learn from it and probably apply it to things. The first thing we do is to go to the file menu. You can go to the file menu and then open raster, or you can click this button here and open raster. So file, open raster, or click this button at the corner and then click and it open raster. That means we want to open that image I sent to you. All right, so this is all we are doing. So all of us, let's do this. File, open raster, and then browse for the image I sent to you. File, open raster, and then browse JPEG map image. Okay, so look at the terms where a JPEG map image. It's not really georeferenced. We are not going to reference it. So you can imagine that it's a map that has been scanned. In fact, this one is someone's project, and then they probably converted it to PDF, and we are now trying to bring it back into GIS. So yeah, it introduced some errors. So you shouldn't be doing this. Like they say it on TV. It's very funny. Children, don't try this at home. It's okay. What we're doing now shouldn't be something you should be doing. Someone's map they've already created, converted it to hard copy or something, PDF, and then you are now trying to bring it back into GIS as a background. Obviously, it won't give you the ideal result. So now, if you've done that, let me also do it, and then we will all be looking at the same thing. So you should be seeing what I'm showing you on the page right now. So if you are not seeing what I'm showing on the page, you can raise your hand. If you have a challenge, let me know. Okay, so the chat for Zoom is not like WhatsApp. So I wanted to paste my screenshot of it, but it's okay. All right, so you should see what I'm showing. It's a map with a compass rose, but there's something with this. This is a picture. This is an image. This is not a vector. So this is where people have a problem. Okay, so anybody in the class can tell me why this is not a vector, but it's a raster? Can anybody tell me? It's a tutorial, doesn't mean we don't talk. Is that okay? So please, can anybody tell me why the image you are looking at is not a vector? Okay, so the question kind of answers itself, but I still want to hear you. Why is what we are looking at a raster and not a vector?
The image is presented in some form, in forms of polygon form.
No, if it is presented in polygon form, then we are expecting it to be vector, but it is not vector. So why are we saying it's not vector? Okay, I think sorry, this is a bit too much for you, but you see, when you look at an image, yeah, an image always has every part of it. There's a square, there's something there. Are you okay? So when I gave you this image, when you actually look at it closely, you realize that this space here, I don't know if you can see my cursor as it moves. This space in your WhatsApp, when you open the image, you will see that it's white, telling you that what I've given you is actually a continuous data. Everywhere there is something. By in vector, there are holes. Let me give you an example that if you take a GPS and you pick a set of coordinates points, you realize that you're missing huge spaces, huge expansive areas. So that is one proof that this is actually a raster. It's an image. An image always has there's this continuous IOK. The values don't stop. As opposed to a line, when you take a line, you just draw the line. Are you okay? And then the rest is just spaces. Are you with me? So that is vector. Polygon, you draw the boundaries. Are you okay? You maybe fill the polygon, but really it doesn't mean anything. It's the boundaries that define the polygon and not the color infill. All right, guys, this is university, so let's feel free and talk about things. It can't get, don't tell me I'm making it complicated. I used to teach some children. One of them said, you're making it too complicated. Okay, but anyway, I think this is just easy. Okay, so this is a raster, and the proof that it's a raster can almost be seen in the WhatsApp when I send it to you. Or if you copy it and you put it into Paint, you'll be seeing it, that the line here is not just what I sent to you. I've actually sent you all these white pixels. Okay, all right. So the pixels can be seen if you go closer. So I'm going to introduce you to the tools that allow us to interact with the data set. Excuse me. I took some chicken and I've drank a lot of water. Forgive me. All right, so now look up here. Is there?
I'm a little bit confused.
Okay, so please, we are not in a hurry. Let's hear you.
You said that the picture that you sent to us is a raster, right?
Yeah.
Okay, but with the explanation, you were saying that it's also a vector.
It's actually not vector. It's vector that has been converted to raster. Okay. Yes, it's vector that has been converted to raster, and so every part of space within the West African area has now been filled with white squares. Listen to these words very well. The ones what I just said. That's a secret to understanding. Every space within the boundaries, including the sea, has been turned into white squares. Is that right?
So that will make it a vector.
Oh, no. Is that right? I want you to just follow it.
Yes.
Okay. All right. So you see that because of that, you don't have a vector anymore. So that if I ask you to represent a road, you'll be picking the center line of the road. Is that not so?
Yes.
Great. But that is the vector concept. If it's a raster, you will be flying on top of the road and you'll be taking a picture of it. Do you see the difference between vector and raster? Is it becoming clearer a bit? So vector is discrete. Listen. Who am I talking to?
Exit.
Eh?
Exit. Benjamin.
Ben. So vector is discrete and then raster is continuous. Think about it. If you have a certain space and you want to capture things vector, you'll be leaving a lot of things. Think about it. A football park will be picked as a rectangle. That's vector. But then raster will pick all the grass and the bare soil. Benjamin, are you getting this? Are you getting there? Are you getting there? Are you getting what I just said?
No.
You're still not getting it?
Yes.
But don't you know a football park?
Don't
you know a football park? Don't you know you can draw a football park by drawing a rectangle?
Yes. When we draw the rectangle,
so why are you making it
difficult
to that? You can draw a rectangle to represent a football park. The same, but you can also take a picture of the football park and it will still represent it. And you show people, okay, that's a football park over there, the green area. That's the football park.
Yes.
Is that also?
Yes.
Yes.
So that one will, like if I put the rectangle around it, then that would be a raster, right?
If you use the rectangle, that's a polygon. You would that would be a vector. That would be vector. But if you take a picture of it, it will capture the grass and the bare soil. In that case, you have raster.
Raster, okay.
So it's representation. The concept of vector and raster is representation. Is that okay?
Okay.
So in this case, let's use the tools up here. Please, I want you to let's start with the pound tool up here. Click on the pound tool and then you'll be able to move the image. So if you don't know what panning is, that is what we are doing. We are panning. Are you okay? This is panning. That means you can move it around. It's nice to do that. All right, let's go for the next tool. Zoom in. I think you know this already. I think some of you are thinking this is too basic. You understand this already. All right, so you can zoom in. As you zoom in, the scale increases or decreases. Christian, if you are listening to me, Christian, as you zoom in, does the scale increase or decrease? So here I'm panning. So Christian has gone to bed, isn't it? Okay, that's fine. So I'm panning, and I'm going to zoom out. So it's getting smaller. So the question to Christian who is sleeping is that am I increasing scale or am I decreasing scale? All right, let's move on. If that comes in an exam, don't come and ask me why I keep it. Okay. But anyway, we can go for the zoom to layer. Now zoom to layer will just zoom to the whole thing. Okay. Zoom to layer will zoom to the whole thing so that if you zoom too close and probably you are lost, you can just click on the zoom to layer and to come back. Like it disappeared, but you got it back, don't you? All right, then we have zoom to last. So what was the last view? So when you click on this, check it there. The last view, we couldn't see anything. All right, so we can keep going back and you can see that we are going back to all the views that we had. Okay, we can have zoom next. That will also zoom to, Forward. It's like forward and then reverse. Are you okay? Please experiment with these tools for just 1 minute. All of you, make sure you are going to be using them. That's why I'm asking you to get familiar with them. The zoom, pan tool. I'm going to use them. So please be practicing with them. Make sure you are comfortable. Let's listen. Okay, so I believe you are good, right? Are you guys? All right, so I can zoom, I can pan. See, I'm panning. I've zoomed so close. All right, so now I believe we are seeing pixels. Okay, can you see the pixels on my screen? This one is like proper pixels, isn't it? Okay, later on I'll show you that you can actually measure and have an idea what the resolution is, which I think we've talked about before. The resolution of an image, okay, is defined by the size of the square, the pixel, okay? So raster, the basic unit for representing a raster is the pixel. So literally we are looking at pixels. But someone also tell you that in fact the real pixels for this laptop are smaller than what you are looking at. So it's kind of interesting. All right. Wait, so we can go back, zoom to layer. Okay, so the next thing is that
hello, sir.
Yes.
Hello, sir.
Go ahead.
So is the line that gave us the pixels? The boundary lines is the one that gave us the pixels?
Yes, the boundary line is pixelating. We're seeing some pixelated boundary lines. Yes. Why do you ask?
I don't know what is that pixel. I've been hearing, but I've seen the way you've done it before. I know that it's a boundary line that gives us the pixels.
You just wanted to know if it's a boundary line.
Yeah.
Okay. I've just told you it's a boundary line. Is that okay?
Okay.
So it means that every image on a computer is made up of small squares like that. But that's a very good way of showing you pixels. But I was just saying that on your laptop, so when you buy a laptop, the screen itself has a resolution. That's what I'm saying, that this is just a way of, this is an exaggeration of what the actual, resolution of the image is.
Hello, so sir.
Yes.
Sir.
Yes.
Hello, sir.
Go ahead.
So when you draw any line,
right,
and you put it in this software, you see the pixel. Is that so?
Please, that's not what we are talking about today. So you are digressing. No, I just wanted to show you something on pixel. I've been talking about pixels in class. Have you been coming to the class? So if you've been coming, I've been talking about pixels. So I wanted to show you a typical pixel, that when you break down an image, you end up seeing the pixels as I've shown on the board at the moment. So if you don't understand the idea of a pixel, look at the picture and then go closer to it. You see the squares that make up the picture. I hope you understand what I'm saying. I hope you understand what I'm saying.
Yes, sir.
Yes. So this is not my focus. I just wanted you to, I just saw them and I thought I should let you know that this is something that we've been talking about. Okay. All right. Also, it also proves that this is actually like a raster, more or less. Okay. All right. So let's move on with what we are doing. So we are going to identify 4 points on this image, which have coordinates. Then we are going to instruct the software and tell the software that These are the coordinates at these points. So we're going to pick 4 corners of this image. So you take your mouse and I want you to zoom to. So you can zoom by clicking and dragging, like so. You click here, you drag it, and you leave it, then it zooms to that square. It's all right. That's a very nice way of zooming. So we are going to read these coordinates, and then we are going to now mark these points down, and then we are going to give it a set of coordinates. So you're going to take a pen and paper or use your laptop, it's up to you. And then I want you to write down 4 coordinates. So this will be point 1, this corner. So we're going to take the top left intersection of the longitude and the latitude. The top left intersection of the longitude and the latitude. Okay, and then we're going to write the coordinates down. Okay, so please, let's do that. Okay, go to the image, zoom to one corner, and I want you to read the coordinates. So I want someone to read this coordinate for me. What are the coordinates here at this point? We are going to write 4 coordinates down. 1 top left, top right, bottom left, and then bottom right intersection of longitude and latitude. Is that okay? All right, so let's do that. Write this coordinate down for this intersection, and then you go to the right hand side and you write this coordinate down, the section between, because this is the farthest longitude and this is the topmost latitude. Please, I hope you are following. Don't wait and then later you say I don't understand. Please, if you don't get it, let me know. It's okay to ask though. I'm not intimidating you. You can ask a question later, like. But
hello, sir. Are we
yes,
writing the 25 degrees?
So right, please. These are let me explain the coordinates to you. Yes, I know where you're coming from. I didn't allow you to read, but let I know where you're coming from. So these coordinates you see at the top are the longitudes, 10 degrees west. Then we have 0. Then we have 10 degrees east. Now, what does this mean? It means that this is the Greenwich Meridian. All right. And I hear that we had there was a guy who actually came up with his own meridian, and he's called Andrews. And so it could have been Andrews Meridian. Are you okay? GMT would have been AMT, but it wasn't to be. I read about it just last week. So the reference line is the Greenwich Meridian. To the left of it, we have west. All the coordinates there are west. To the right of it, all the coordinates there are eastern. Up to 180 degrees, because then you are at the half of the Earth is now kind of gone to the very end of it. All right, so now this is what we're doing. Understanding these coordinates mean that this is a value for this longitude. Yeah, this is the value for this longitude. This is a value for this longitude. This is the value for this longitude. And we want to write the intersection of this line, the latitude here, 25 degrees north, and then 10 degrees west. So give this point a name or a label. You can call it 1, you can call it 2, and I want you to write the coordinates down. Please, do you understand what I just said?
Yes, sir.
Yes, sir.
This is very easy. This is GSS graph.
Yes, sir. Yes.
Don't let me.
Yes.
Please, this is very easy. Just write the coordinates for the left, top right, bottom left intersection of longitude and latitude. This can be an exam question. Just that maybe you're not taking it serious, but it can easily be. Please. So write
all the corners.
The 4 corners. So we need 4. We need 4 of them, please.
Okay, sir.
So I'm going to show you how you do this. I think it's only fair I do that. So the coordinates here, we can call this point 1. Write this down. 1. Then you just put 10, comma, 25. For example, this will be the coordinate for this. So it's like x and y. So write it x and y. Write it in that order. Okay. There is no decimal, so it's really 25.0, 10.0. Okay. There's no decimal. You are going to go to the second point, and then you're going to write the coordinates down. Third point, write the coordinates. Fourth point, write the coordinates. Then you get 4. You know, but the first point is top left. And the second one is top right, intersection. Then we have the third one with bottom left or right. It's up to you, bottom right. So you should know what you are putting now. Now, if you tell the computer that give it the wrong coordinates, when you finish, the whole thing will look very nasty. You wouldn't like what you see. So please, it's up to you. Be honest to yourself. Bottom left. Okay, and then put the coordinates here. So I'm expecting you, excuse me, the student. Oh, okay, excuse me, to put in coordinates here. I've left it empty, so you shouldn't leave it empty. I want you to fill it in and then show it to me. I want to see it. Is that okay? In the next 2 minutes, the WhatsApp session will end. I hope that in just 1 minute, you can probably write all these coordinates down and we can share it. Then we can go into the next meeting.
Hello, sir.
And then, yes.
I finished writing it on my paper, but I can't put it on my screen.
Okay, what do you have for 2?
Like have you done it?
Hold on. Hold on a second for me. What do you have for top right? Coordinates.
The same thing.
Okay, so for your information, someone I heard someone say it's the same thing, right?
Yeah, it's the same thing.
It's not the same thing.
It's not the same. It's not the same thing.
It's 10, but that one is. And this
the other one is negative.
Sir.
The other one is negative, but nobody saw it. That it was on the other one. The first one I did, the one is negative.
Yes, sir. I was tempted to say it because of the direction.
Yes, it's on the left side of 0, so it's negative 10, 25. So that 2 can be just 10, 25 without any negative sign. Okay, so the Zoom session is ending. Please complete the rest. 3 and 4. Okay, give us 3 and 4 before it ends. What is 3?
Sir, I got 3.
Sir.
25 degree and
3.
10 degree.
No, sir, it's 5, 10.
It's
negative 5, 10.
Oh no, but it's not negative 5 because
it's 25.
5 is the y, 5 is y, so you don't start with yx, you do xy. Are you okay? So you need to check yours.